Perfect. So we are live and yeah, good to go. Amazing. So again, as I mentioned, today we cover Kubernetes from scratch, and today's session majorly would revolve around understanding why we require Kubernetes at first, and then we'll understand the architecture of Kubernetes. Now, understand this is very important from interview perspective because there are certain terminologies which may not be understandable to you at the first place, but again, once you start learning them more, like sort of running the documentation and everything, it'll get clear for you in the course of time. So do not just panic if certain things don't get into your head today, because Kubernetes as a whole is a very vast topic. It's not something that we can be covered in a single session. But again, I'll try to give you a brief understanding about why we require it at first. So we'll understand why do we need Kubernetes at first, and then deep dive and understand what is the actual architecture behind Kubernetes and everything. So this session will not have the hands-on. We'll see the hands-on in the upcoming session. And yep, good to go. So let me just share my tab screen, and we'll be good to go with the. So initially, as I always do, right, we'll try to understand what is the history behind Kubernetes, right? So let me just set up my systems. Perfect. Perfect. So let me just get it started. Perfect. So I hope my screen is visible to you, all of you, and let me just check up once if the screen is visible. Just let me know in the chat once if the screen was visible to all of you. Anyone, just ping up in the chat maybe. Perfect. Okay, great. Cool. Let's begin. So first of all, if you remember, I'll just summarize what we covered in the last session. So last session was about Docker, and we understood why Docker came into the picture. Initially, we covered topic of containerization, and with the course of time, we explored uh, virtualization versus containerization, and then Docker as a tool, how you can implement containerization using Docker. We saw concepts of Docker in Docker. We understood the architecture of Docker. But if you remember well, we were talking about a particular term for a very long time in the last session, which was um, configuration management. If you remember this, right? So there was this term which we were covering quite a bit of time. So we were talking about making some configuration changes and requiring some tools to do this for us. So configuration management came into the picture in the last session. So today we understand why we require configuration management and how does it actually help, and how Kubernetes sort of is very very important when we talk about that, right? Cool. So to understand configuration management, let's understand a bit about software development, or what was the software cycle development cycle looks like, right? So initially, let's say I have an application here, right? This is my app. Now this is a server where my application runs. So let's say I have another app. I run it on another server. I have another application and I'll run it on a different server, right? So I am requiring three different servers to run different versions. So this is my V1, this is my V2, and this is my V3. So I require different servers, right? Or maybe call it VMs to run three different applications, right? So this is not effective. So let's mark it cross. So this is not at all effective. This process is not at all effective. So then came into the picture of Docker and containerization, right? So Docker and containerization said what? They said, you know what? We just give you an isolated environment. So let's consider this to be what? This is an isolated environment, right? And under this environment, you can have multiple containers, right? And each container can have multiple applications, right? Right, that's a benefit, right? So but again, let's take a condition that we have a situation here where we are running sort of 500 containers. Now that's a very big number, right? And managing this 500 containers manually is going to be a bit of difficult, right? So let's take it as a constraint. Constraint number one is management of large number of a large scale of containers, right? Moving ahead, there is another problem that we see. Let's say my application is running on container A, right? This is my application, and this is running in where? It's running in container A, right? Now this is a running container. So let's say we have container A, we have container B, and container C. All right. So my application right now is running here, and it's in the running state. Perfect. Now let's say I want to shift the version of A to B, right? In containerization, to do this, we'll have to sort of change the entire container, right? There is no possibility of sort of implementing changes directly to the same container, and in that case, we'll have to take our container down and then again put the container on. So that's a really difficult task to do. So again, this is another constraint number two, right? This is our constraint number two. That's like mutability or immutability of applications when running in containers, right? Let's give that name. Perfect. And another thing is that, let's say we are, of course, our application will run in certain infrastructure, right? So let's say this is my application, and it will run in some infrastructure, right? Now how do you sort of track or log the changes that you make throughout the course of the development cycle in from your application, which is in a container and infrastructure? How do you log it, or how do you track it, right? So this is now, we can consider this to be a constraint three, right? Cool. So because of these three parameters, we came up with a topic which we covered in the last slide. That is what, if you remember well, it was configuration management here, right? So this what led to this term, development of this term of configuration management. So what it says is nothing. So configuration management refers to sort of defining a default behavior of your environment. Okay. Now it has few benefits. So let's say CM, let's call it. And the benefits are, the first one, it's immutable. Okay. Now, what does it mean, right? What is immutable refer to here? So when you see immutable for a particular infrastructure, or let's say an environment, what we're trying to say is that, let's say my app is here and it is running on a particular container. I want to add second version of this application. I cannot make changes to it directly. Okay. Just changes on a running application is not allowed. What I'll have to do is I'll sort of stop this container and create a new container and put my version 2 there. So that's what immutability refers to, and it is supporting a very important topic in terms of DevOps, that is reliability. So it sort of supports or uplifts that, right? Cool. The second major benefit is that you can manage your changes, or you can sort of call it maintaining your changes in the infrastructure using the configuration software, or you can call it SaaS, right? So you can manage changes to your infra using software, which makes your work pretty easy, right? So these two are the major benefits, okay, that came into the picture from this term of configuration management. And again, Kubernetes, when we say K8s, right? Kubernetes implements configuration management, okay, but it also does a lot more. So, but it also does this. So you need to sort of relate or sort of find some relatability in this case, right? Cool. So that's one topic that you should know. The second topic that we'll cover is, if you remember, or if you have worked with a Mun stack or something, you probably have heard about this term of package managers, right? So let's call it package managers. So npm, yeah, yarn, right? So let's give it some npm and yarn and other things, right? They are the package managers, etc. Right? Cool. Now, before jumping into it, let's talk about a bit about how software development lifecycle works, right, and how it has been working since traditional days. So I'll take an example here. So let's say we are building an application, let's say a full stack application, right? So what do we require in the full stack application? So let's say this is my full stack application here, and the first thing that I require is my front end, right? So I'll require my front end, I'll require my back end, right? Very basic. I'll require a database, of course, right? What else do we require? Anyone? We'll require, let's say, chat messaging support, right? What else? And let's say we require some networking components, right? Cool. So we require this few things, right? Now, whenever we are building an application, and this all these parameters are sort of buckled around or sort of packaged around a single code base, or like let's say a single place, right? We are running all of this in the same server. That's a very famous term for just referring this, which is monolithic. So this is a monolithic example, okay? And this is not what we implement in today's day. This is not preferable. I'll tell you how. So monolithic applications were designed, right? And then people found, so let's say I want to change something in my database, right? And I want to push some changes here. So while deploying, I'll have to deploy this entire set of code base. Why? Because all of these are working together under the same code base. So that makes a bit difficult for us. Make sense? Now, to solve this problem, something came up, and that is known as microservices. So what is microservices? So microservices are nothing but it's sort of a segregated version of monolithic application. Okay, so here, every component that we talked about, let's say front end, back end, database, chat messaging softwares or APIs or whatever you call it. What else do we have? We have networking components, right? Cool. So all of these things, they work around in a single server. Okay, different servers, and they have different environments. Okay, and there is something which sort of connects all of it together, and then comes the application, right? And this something is very very important in this session. Okay, this is where we are targeting. Cool. So the benefits are very simple, right? We don't have to focus on each module or each component while deploying applications. Our deploying applications, consume less resources, right? And small changes require very less time to fix, and you don't really have to run a lot of checks, because let's say I make a change here, I will not run checks here, 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 and here, right? I'll just run checks for networking components, right? So, which is very easy for me, right? And if you don't know what checks means, I'm talking about CI, right? So let's say if I push some code to GitHub and I want to check if that code is compatible with the application, I'll run some checks, I'll run some builds. So let's say I run some, like I change some networking component, my tests will only run for networking microservice, not for the other microservices. So that's another benefit. Cool. Moving ahead, right? Then came to support microservices, right? Containers came into the picture. Just a minute. Cool. Yeah. So to support microservices, containers came into the picture, of course, right? And containers said what they said. We provide isolated environment. Now, let's say there is a sort of a defect somewhere, so we also provide fault isolation environments. So there's a very famous term, fault isolation. It supported that. So let's say there is a problem with networking, so we'll only deal with networking on a single container. We'll not involve other components here and there to sort of fix this or sort of relate to this, right? The changes are only done here, and this is the only thing that will get pushed and that will get updated. The container will automatically spin up. So basically, this will automatically spin up the only those containers where networking applications or sort of code bases are stored, right? So, but again, to run the application or to make this application live, we need to make all these sources or components communicate with each other, right? And there has to be a manager who manages this communication, right? So this is where a famous term comes into the picture, which is known as orchestration. Okay. So I'll relate this to a very famous example, and I think that will make things very clear for all of you. So then comes a term known as orchestration, right? So if you have ever seen an orchestra, right? So let's say there are some people here, right? These are band, right? Now there are some people here as well, some people here as well, right? So they don't look like people, but consider them to be like people. Okay. Now these guys are piano guys, these guys are violin guys, and these guys are drum guys, right? Now when in an orchestra, right, if you have observed in YouTube or any other platform, you'll see that these guys are playing, but they're sort of following certain patterns or certain commands or certain rules, right? And just there is one person in the middle who is sort of playing around with his hands here and there, and he's sort of guiding them or sort of telling them that yes, this is that, and everything, right? So this person here is an orchestrator, right? He's known as an orchestrator, and this entire process is known as orchestration, right? Same thing happens here, right? My orchestrator in my application or in the application infra or whatever you call it, it defines how you can deploy and your manage how you can sort of deploy and manage applications dynamically, right? So this manager in the previous slide that we see, this is nothing but this is an orchestrator, right? And Kubernetes is an orchestrator. Okay, so that's the first definition that you heard from me about Kubernetes, right? So again, orchestration supports various benefits, right? That you can deploy dynamically, right? Of course. The next benefit, whatever, so very less downtime or probably zero downtime, you can call it, right? Then there is, you can update and scale very easily, right? Pretty easy, without any downtime. You can update and scale resources whenever there's a requirement. And also, let's say you're running 500 containers. We took this example, right? And let's say out of these 500 containers, 20 containers are failed, right? So what to do with these 20 containers? So basically this orchestration will also deal with healing and restarting containers and other, allocated resources, right? And it will do it by itself, right? Cool. So again, these are the major sort of features of orchestration, right? In an orchestrator like Kubernetes. But these are also features of the entire cloud native space, right? So when you say cloud native, so these are all the features of cloud native as a whole. Okay. What is cloud native? Now, application that uses, or sort of, how can I like that sort of, yeah, that application that uses Kubernetes or any other tool which is similar to Kubernetes, or does the same work, you can call them as cloud native applications. And the entire space is known as cloud native. Now, if you have heard about CNCF, right, Cloud Native Computing Foundation, they have hosted a lot of tools and projects under them, which are sort of following these practices, and they somewhere implement or sort of support either of these calls, right? So yeah, that's it about cloud native. Now again, some people may confuse with it with cloud computing. Now again, when you say cloud computing, it means you are talking about using some cloud resources, and when you're talking about cloud native, it means you're implementing orchestration, or the features like this mentioned here, right? That's it. Cool. Moving ahead. Um, so again, as I mentioned, right, there is something known as Kubernetes, which sort of supports orchestration, right? So this is K8s, which is the famous name. We call it K8s most of the time to reduce writing Kubernetes as a whole, right? Okay. So again, Kubernetes can be used. Let's sort of list down the features, right? So Kubernetes can be used in public cloud as well as private cloud. Okay, that's the first advantage, right? Now it helps your migration easy. So if you're migrating your application from once, let's say you are using some CI/CD tools like Jenkins, right, or Circle CI harness. So you're migrating from one place to another. Your migration is very very easier when you're using Kubernetes or any other orchestration tool, right? And then you also have zero downtime support, of course. Using Kubernetes, you can make sure you can allocate resource automatically, and you can auto scale and stuff like that, right? And you can have zero fault tolerance as well, so it supports fault tolerance. What else do we have load balancing. It's a very important term, we'll cover next session what is load balancing. So it sort of supports that as well. And we have scheduling, right? So you can schedule containers, and again, it's a very vast term, we'll cover it in some time. Cool. And of course, yeah, and then also you can have handles, sort of plays around with secrets and stuff. Okay. And there are a lot more. Okay, I'm probably missing a lot here. So Kubernetes makes it very very easy to work around with containers and with all these features, and it sort of facilitates when you are working around with, like, you don't really depend upon sort of to manage. So again, like Kubernetes, there are multiple other tools as well. Okay, and Docker has something of its own. But with Kubernetes, it becomes very versatile because it follows the open, um, uh, yeah, so Open Container Initiative, right? OCI. So it follows this. Kubernetes follows this. So it makes it pretty easy to migrate, to sort of change your tools, change your infra, change your environments, anything. Okay. So people prefer Kubernetes for mostly for that purpose, right? Uh, cool. So how Kubernetes came into the picture? Let's see a bit about it. I'll not cover most on that one. Let's see a bit about it only, right? So basically, there was Linux, right? Linux guys were building Docker and everything. So there was this time where AWS came into the picture, right? AWS said we will migrate on every resource to cloud, right? They came and said this, and people were not believing them much, but with course of time, people started believing them. There was another very famous company, if you have heard about them, OpenStack, and they were doing something similar. Okay, but they again did not got that, they did not have so much resources, but again they failed with the course of time. So Google, in the meantime, was working with a project, okay, internally for Google team, and the project name is Borg, if you have heard about it, right? And there was another project, if I'm correct, Omega, right? So Borg and Omega, they were using internally, right? And they sort of were implementing this container runtime interface for a long period of time, right? And they were sort of using the orchestration, but they did not name it. They were using orchestration and their features while they were working around with Borg and Omega, right? So after a point of time, Google folks came together, right? And they started working on Kubernetes, right? Something known as Kubernetes, right? And with the course of time, they made it open source. So they made Kubernetes open source, and they submitted or sort of donated this project to CNCF for maintenance, right? So CNCF now maintains it, right? So if you have to understand in one word what you can consider Kubernetes to be, so it is nothing but very famous term. Okay, it is OS of the cloud, so operating system of the cloud, right? That's how you can sort of relate to it, right? And that's it. That is pretty much it about the history of Kubernetes and how it came into the picture. Cool. So let's understand a bit about the architecture of Kubernetes now, right? That's very, very important, and most of the times people will ask you in your interviews and everything as well, right? So let's say architecture of K8s, right? Amazing. So the first thing that comes into our mind when you say Kubernetes is clusters. Okay, so very famous term, right? So what is a cluster, right? So cluster is a combination of something known as a control plane and nodes. Okay, so what is a node? I'll tell you in some time. Okay, so sort of cluster control plane and plus nodes, you call it a cluster, right? So how you can define a control plane is, let's say this is my control plane, right? This is my CP. Let's give it a name, CP, right? So there is, just like in Docker, we had this Docker CLI, right? Which used to which was helping us to in terms of communication. In Kubernetes, we have kubectl, which is a CLI tool. So we have kubectl, right? Now this is a CLI tool which communicates, okay, with the control plane. And let's say there are 500. Okay, just a minute once again. Uh, cool. Uh, okay, lot many questions. Let me just complete all of it and then sort of come back. Okay, yeah, amazing. So as I was mentioning, right, there is kubectl, which is a CLI tool which interacts with control plane that in the cluster, right? And let's say we have 500 containers right now. You want to assign each container to one node, right? So there can be multiple nodes. Okay, there can be multiple nodes, right, together, and then there is a control plane, a big one, right? So CLI tells the control plane that, you know what, I have these applications of different version, now assign it to different nodes, right? Now each node can have multiple containers under it. Okay, so control plane then decides where to send that information, and it sort of in some way manages the nodes. Okay, let's say these are the nodes, so control plane manages these nodes. Okay, everything, right? So again, cluster is as I mentioned, collection of nodes, or you can also call them worker nodes. Okay, nodes, you can call them worker nodes. And control plane is nothing but it's a master node. Okay, this is also a node. Okay, just being very clear, so this is also a node, but we call it a master node. Correct. Cool. So moving ahead, how sort of let's say let's cover a bit of kubectl about for giving some information about kubectl. Yep, so this is a CLI tool, as I mentioned, right? This interacts with the control plane to do anything, right? The communication with control plane is handled by kubectl, right? Amazing. And now there are two ways with which you can come sort of work around with Kubernetes, right? There is a declarative way and there is an imperative way. Okay, So let's write it down as well. Now I am not sharing any notes for these things. Now if you want to make notes, you can make it. But there is nothing much to make notes. You can read a lot of online books and stuffs as well. Articles are there. You can follow me on Hashnode. I write a lot of articles around how to get started with Docker and Kubernetes. So that is also helpful. But yeah, again, if you want to write notes, you can make notes. Okay. So there is a declarative approach and there is an imperative approach, right? So what is an imperative approach? Now let's say you are sort of working around with Kubernetes with commands, right? So when you're working on the Kubernetes with commands, it's an imperative approach. And then there's a declarative approach where you sort of declare what your orchestration should be like, or you tell kubectl that, you know what, this is what I want, this is what you should do, right? So you just define it in a curriculum sort of a thing, right? So there are so in this case you write manually YAML files, right? Or you can call them manifests as well. Very famous term. Now this is not English manifest. This is DevOps manifest. Okay. So these are called manifest files. So once I was talking to one of my friends, I said manifest, and he mentioned a Netflix series. So this is not Netflix series. This is a file that we declare in order to work around with Kubernetes. Right. Amazing. So again, so that's about the approach that we can take. Now there is another very important term here, which is objects. Okay. So let's say K8s objects. Okay. So what is a K8s object? K8s objects are nothing but they are like, we call them pods. Okay. And what are they used for? They are a scheduling unit. Okay. So you schedule everything using pods. So if you have worked around with GCP and you have created GKE clusters and everything, you probably know that, there are a lot of what to say, pods, right? You declare pods, and then if you are able to run your builds or your tests, everything depends upon if you have schedulable pods or unschedulable pods, depends upon the resource allocation that you have made. So that is only this, that there's nothing much time here, right? Now if I have to again write down the infrastructure or the architecture of Kubernetes again from scratch, so this is what it will look like, right? So this is my infra, right? And there I have my let's say this is my worker node, right? This is my worker node. So I have already completed CP, that's control plane. Now let's understand what worker node has, right? So worker node has the container runtime in it, right? So let's say this is a container runtime, CR, right? And then inside it we will have pods, and you can have multiple pods, and pods you can consider them to be like containers as well, right? Inside the pod you can have containers. So inside the pod you can have containers, and you can have multiple containers inside a single pod, right? Cool. So that's pretty much it about how Kubernetes works. Okay. Now I'll just briefly let's just understand in the single diagram of how Kubernetes works. Now these diagrams you can find them in online as well in articles and stuff. Now not nothing much. You can have like usually you can take screenshots and stuff as well. Works fine. So the architecture somewhat looks like this. Okay. So this is my entire plane, right? And inside it I have my control manager. Okay. Or you can call it a controller in short, right? We can call it controller in short. So what controller does is it manages servers. Okay. So there is an API server in Kubernetes. Okay. Let's give it an API server. Cool. So controller, what it does is it sort of communicates with the API server. Okay. And it, after communicating with the API server, it does all its operation. And who does the communication with the API server is kubectl. So as soon as you run a command, kubectl directly moves inside and talks to the API server, right? And the API server then decides where to send this data, right? So there is a tool known as etcd, right? So it decides whether the data should be moving into etcd or what it should do, and depending upon it, it sort of scales or sort of shares the data across the entire architecture. And then there is another component, as I already covered, that is known as schedulers, right? Which schedules deployments and sort of everything, right? It decides the deciding factor, right? It also communicates with the API server so that it gets, or it can fetch data from directly from the API servers, right? So communication again happen only via the API server throughout this architecture, right? And you can define this communication using YAML files, that is manifest files, right? and that's pretty much it about it, right? And if I have to give a brief understanding about what etcd is, right, so let me just cover that as well. So what etcd is nothing but an open source tool, right? It is an cncf project. You can go and search about it in cncf infrastructure or ecosystem. So it is an open source tool, and it sort of stores the entire data. Okay, it stores all the data about your cluster. That's it. Okay. In and this is stored in a database. That's again very important. It stores in a database, right? So if I have to again define the workflow, so we have this schedulers, right? It sends commands, right, and physically schedule the pods, right? It schedules the physically schedules pods. Pods are nothing where your containers lie, right? And api server facilitates this communication, right? And by default, API servers are open, like the API server of a Kubernetes cluster. It is open in port 443. Now, these are very important terms. You can just run through them. Like these are MCQ questions which comes up in tests where you are, whenever you are appearing for Kubernetes and stuff. Cool. Now again, if you remember, we talked about two types of managers here, right? One which is a controller management manager, and then there is another which is known as the image manager. Okay, so both the things are part of the same ecosystem, so there is nothing much of big difference here. We can refer both of them as the same tool or same component. They just work parallelly with each other. Okay, and yep, that is pretty much it about how the work sort of scales between the worker node and the architecture of the API server and everything, right? And what else do we have? Anything I'm missing? Cool. I don't think I'm missing anything. That works fine. Okay, there is something known as, okay. I just mentioned one tool of the CLI, that's kubectl. There are others as well, right? So there is something known as kubelet, right? This is useful for listening to the API server. So the API server that communicates, it communicates via kubelet. Okay, the command that you use is kubelet. Okay, or you can say the tool or the component is a kubelet. And there is another known as kube proxy. Okay, what kube proxy does is it communicates with the sort of it sort of communicates with the controller. Okay, the controller that we define, it communicates with that directly. And what is it controlling? It assigns IP addresses. Okay, it works in networking domain mostly. It assigns IP addresses to the nodes. So every node has their own IP addresses. So it assigns that to this and sort of talks to the communication with the controller, right? Cool, amazing. And that's it, right? That's pretty much it about the architecture and everything. I don't think there is anything else. Okay, there are two other topics as well, which is DNS. Okay, but again, let's cover that in the next session. Okay, just to give you an idea, there are two types of DNS. There is Kubernetes DNS, or you can core DNS as well. So we'll see this sort of helps understores and everything about IP addresses and networking stuffs and everything, right? So we'll cover them with the course of time when we see the hands-on demo and everything. And yeah, if I have to again just summarize the entire workflow, right? So if let's summarize the entire workflow. Cool. So first of all, we have containers here, right? This is my container, right? The container is inside what? It is inside the pod, right? This is my pod. Now the pod is stored under a particular workflow or under a particular, uh, you know, uh, whatever you call it, node, right? Or you can call them deployments, right? So let's call them deployments. So this is under deployments, right? And that's it. That's the entire architecture and the sort of inherited architecture of the entire Kubernetes ecosystem, right? Cool. So let's cover some questions now. Um, okay, I think. Was the screen not visible to all of you? I'm not sure. I don't see my screen presented. Okay, let me just cover this again. So yeah, that's it. This is the entire architecture, how it looks like, and We also covered about how the API servers interact with the port 443, the code K8s DNS, the core DNS. We talked about kubelet, which sort of listens to the API server. We talked about kubeproxy, which assigns IP addresses to the nodes, and it sort of communicates with the controller, right? And this is the entire architecture of how the entire system works in a sort of worker nodes, right? There is a scheduler, there is a controller, there is an API server, and there is etcd. And kubectl talks to the API server. There's a controller which talks to the API server, and the API server decides where to send the data. etcd stores the data in terms of all the cluster information in database. Scheduler schedules pods, right? And this is how the worker node structure looks like inside worker node we have a controller, right? And inside the controller we have the containers and the pods, right? Perfect. We talked about kubectl. We talked about the different approaches that you can take, declarative as well as imperative, and Kubernetes objects, which are pods. And pods are nothing but schedulable units. And kubectl is a CLI tool that we use for communication with control plane. Um, and that's it, right? Anything else? No. That works fine. Cool. And this was a history that we talked about how Kubernetes came into the picture. Google, Bog, Omega project, right? CNCF. Google started building Kubernetes and then donated this project to CNCF. That is a cloud native computing foundation, right? And if you have to define Kubernetes in one word, you can call it OS of the cloud. Cool. So let me take some questions now. Um, I see a lot many questions. Cool. Yep, I just summarized the entire thing. What settings, components and interaction between them? Yes, I already drew the components and everything. Ramsing drama. What is content runtime? I think we have already covered this in the previous session. Ramjat, you can refer to the previous session in YouTube. That will be great because again we are. That's how the engagement will increase. I can explain it in this session, but let's take you to the previous session, right? It will be much more easier for you to understand. Any other questions that I should we? Uh, why RBAC component exists in Kubernetes? Again, this is a very sort of what to say, advanced topic. We'll cover it probably tomorrow. I'm not sure if I'm covering it tomorrow as well, but let's see. Again, RBAC is related to security and other giving access and stuff like that. So we'll see if we can cover tomorrow. If time permits, we'll definitely cover. Uh, which Kubernetes component is responsible for providing access to the Kubernetes API? We have the Kubernetes API, as I mentioned, right? We already have uh, the API service which communicates with everything. So yeah, that API service deals with all the communication, or you can call it the sort of scheduling all the server communication. You can call it like that. What is a service account? Now this is a CI/CD topic, Wilson. I'll not cover it in this session. We'll talk about it when I cover CI and CD specifically. Which CTL command can determine if the current user can perform a given action without invoking the API action itself. So Austin, let's cover this in the tomorrow's session. That's in the hands-on session. There are pretty much advanced questions. I see a lot many people. I guess this is great. You guys have some basic knowledge in Kubernetes. It's amazing. But again, keeping this in mind that some people may not have this much of experience and stuff. So let's just keep it for some time for the next session as well. Cool. Amazing. So yep, that is pretty much it about what is Google Container Engine. Okay, let's jump into Google Container Engine and understand what Google Container Engine is. If we Yep. So there you go. We don't. So Google Container Engine, or you can call it GKE, is a cluster management and container orchestration system developed to run and manage Docker containers. Now, after this definition, let's come back to your topic, and then let me just present my screen. I think it's already presented, right? Let me just go back to my tab once, and let's cover these questions. And I mean, it's a good thing to cover because it will give a brief understanding about what how cloud computing is related to containers and Kubernetes as a whole, right? So we have different cloud servers, cloud providers, right? Cloud service providers, you can call them like that. So all these cloud providers provide support, or you can call services, and one of these services is providing support for orchestration, right? Now, how do they do this? So every cloud provider, AWS, GCP, we have Azure, we have DigitalOcean, right? And anything else that I'm missing right now? We have Sivo, right? All of them have their own services, okay, or you can call products. So AWS has their own service, GCP has GKE, Azure has their own Kubernetes service, DigitalOcean has their own Kubernetes service, and Sivo also has their own Kubernetes service. The difference is nothing. The only difference is pricing and how you can use those resources. Now in GKE, there is a very amazing feature of auto scaling. Okay, so what is that? So let's say if you are creating a cluster in Google Cloud, it will auto scale whenever there will be resource requirements. It's a very amazing feature. So yeah, every cloud providers have some unique facilities given to them. In our case, we'll be using Google Cloud, that is GKE, and also a bit of CVO. I'll be also using CVO. So yeah, that is how you can define GKE or Google Container Engine and everything. Right? Amazing. Uh, what are federated clusters? Let's These are very advanced topic. What is the need for container orchestration? As I already mentioned, right, container orchestration is very important because you let's say if you have 500 containers, 1,000 containers, and some containers may fail, some containers may not be healthy. How you are going to work around with it? You cannot delete or stop the containers directly, right? You have to spin them up, you have to restart them. Who is going to handle it manually? It's not possible. All right, so you need to have someone automatically or dynamically managing those. That's why we require container orchestration. What is the difference between Kubernetes and Docker? That's a topic for tomorrow. Yes, as I mentioned, there are multiple tools to orchestrate your containers, and Docker is one of them, right? And so we'll cover the differences and why people love Kubernetes and everything. So if you see, the presentation is ready here, right? It's already ready, but we'll cover it tomorrow. Amazing. Cool. So let's keep it till today. Tomorrow, let's catch up once again, same time, right? Uh, Let me share the event links and everything. Yeah, just let me share all the details here itself. Just give me a minute. I'll share the RSVP link as well so that you guys can sign up directly there. Okay. So, yep. Amazing. Public event page. Yep. So you can just directly jump into uh, the website, right, and register for day 7. And okay, let me share the Hashnode account as well. Make sure you follow me in Hashnode for upcoming blogs. So all the notes that you are referring to right now, you can refer to the blogs and articles that are right in the upcoming time. So just follow me up, subscribe to the newsletter. Let me share the newsletter link as well. Maybe that is helpful for you guys. Just a minute. Cool. So there you go. So make sure you subscribe to the newsletter as well. And yeah, that's great, right? Great session. Good to see so many people interested and so many queries. Would love to catch up with all of you tomorrow once again and discuss more on it, right? So thank you so much everyone for joining in, and make sure if your friends or any connections who are willing to join the session, make sure you share that to them as well. This is completely free right now. You don't find DevOps tutorials free, trust me. So why not help your peers, right? So make sure you ask your friends and connections to join the stream if they're free and they can sort of learn something new, right? So yeah, thank you so much for joining in. Let's catch up on the next session. Bye bye.